Okay, so we have now finished the topic of differentiation. The next topic that follows on is going to be integration. Okay, so I'm kind of changing the way I'm going to be teaching things, just so it's more like a lesson as such. Okay, so feel free to pause this video at any point, to rewind it, to go back. It's up to you, it's just a video. Okay, so what I'm going to start with is a starter question. That's what I'd always teach a lesson, just so we can recap previous knowledge. Okay, so this one is from 2010. So can you pause this video and try these questions by yourself? And then when you're ready, just press play again, and then the full solutions are on the next slide. Okay, so pause the video now. Okay, and when you're ready, here are the full solutions. So both questions are out of 3 marks, and I've shown you where you're finding each mark. Okay, so pause the video, correct your own working, give yourself a mark out of 6 for this. Okay, now we're going to go on to the first topic of integration, and it's just a reminder from higher. That's it. Okay, so in your notes jotter, I am going to do it at the same time as you guys, so can you copy this down? So, reminder from higher. And I've just got about 5 or 6 questions that we're going to go through, and then start working through our new functions for this. Okay, so examples. So number 1, so if you write this down, so integrate the following. So part A, starting off nice and easy, I want you to work out the integral of x cubed dx. So feel free to pause this to work out by yourself, just to challenge yourself. I'm going to go through this. So for integration, all we're going to do is increase the power, so it's to the power of 4, and divide by the new power. But if you just write this down, you're not getting full marks. They are really strict at advanced higher level. You need to have plus C in here, so you need to have your constants. And that's enough just to get you full marks. Obviously, starting off very basic. On to part B. This one's a bit more difficult. Okay, so it's the integral of 8 minus x over the square root of x dx. Okay, so you might see this. Your first thought that might be going through your head is the quotient rule. Now remember, the product rule and the quotient rule are only for differentiating. Forget it when it comes to integrating, because it's not, there's no quotient rule for integration. So we cannot use that at all. Okay, so what we're going to do is, the first thing I can see is the square root of x. I don't like that. Let's change that to x to the power of a half and see where we can go from there. So x to the half. I'm also changing my answer in red pen, just so you can see the questions in blue and the answers in red, just so you can keep them both separate. I'd recommend you do the same. I've got a little bit of OCD when it comes to my notes. Okay, now there's not much else that we can do to this. What we can do is actually separate this into 2 separate fractions with the same denominator, of course. So I can have 8 over x to the half minus x over x to the half dx. Right, these are still not ready for integration, but what we can do is use the National 5 rules of indices and bring this x to the half up to the top. So remember, if you do that, it changes the sign of the power. So still keep my integration sign. If I bring this x to the half up, that's just going to become x to the negative half. Likewise, if I bring this up, on the top we've got, pretend that's x to the power of 1. So if you bring this bit up to the top, it's going to become x to the negative a half, but then 1 minus a half is just going to give you a half. Okay, so I think the hardest part about this question is actually all the working you have to do before you integrate. So now they're both ready for integration. Okay, so we're just going to do the same. We're just going to increase power, divide by the new power. So if you increase negative a half by 1, that just gives you a half. And divide by the new power, so we're dividing by a half. Same with this part here. So increase power. So if you add 1 to the power, you're going to get 3 over 2. And you're dividing by 3 over 2. And please don't forget about your plus c, otherwise you will not get the mark. Obviously, this looks very messy, and we're not going to leave our answer like that. Now, if you've got a fraction on your denominator, what you can actually do, see this wee 2 here? You can bring that up to the top and multiply that. So 2 times 8 just gives you 16. So what this actually is 16x to the half over 1, which is just 16x to the half. Likewise, we can bring this 2 up to the top, so that's just going to become 2 over 3 x to 3 over 2 plus c. Okay, and then there's absolutely no point in changing that back to a square root sign. You don't get any extra marks. Okay, so you're going to get full marks at that stage. Part C for your revision from higher. We've got the integral sign of 2 over bracket 4t take 5 close bracket cubed dt. Okay, so at the minute this is not ready for integration. What we need to do is to bring the bracket up to the top, the same as the previous example. We're going to change that 3 into a negative 3. So bring the bracket up to the top, change that to a negative power, and now we're ready for integration. Okay, so we're just going to use like the chain rule in reverse and such. So bracket stays the same. We're going to increase the power, so it's negative 2. We're going to divide by the new power and also divide by the derivative of the bracket, which is going to be 4 in this case. And don't forget about your plus c. So if we tidy this up a bit, what we're going to get here, let's talk about that. 2 bracket 4t take 5 to the negative 2, and that's all over negative 8 plus c. Then obviously your 2 over negative 8, that's just going to give you negative a quarter. So you can just, there's different ways that you can do this. You can actually just keep that as negative a quarter, and you can bring this bracket back down to the bottom if you want, so it's a positive power. It doesn't actually matter, as long as you simplify that to negative a quarter. I'm just going to keep that bracket up the top, just like that. There you go, and that's how you do that one. I've got 2 more examples from revision from higher. So part D is going to be the integral of 4 cos 2x plus pi over 3 dx. Now you might have noticed that I always put brackets around a cos or a sine, whatever it is. Okay? You see, if you didn't have brackets here, that would actually look like 4 cos 2x, and the plus pi over 3 could be completely separate to this. So make sure you just stick brackets in there just to keep yourself right. Okay, so to integrate this, you need to know that cos, what happens to cos when you integrate it? It goes to sine. Okay, so 4 stays at the front, cos goes to sine, brackets stay the same, and we're going to divide by the derivative of that bracket, which is just 2. And you get plus c at the end here. Here, dead obvious that we've got 4 over 2, which could just be simplified to 2. Everything else can stay the same because we can't touch whatever's in this bracket. And that's how you do that one. If I'm going too fast for you, just please feel free to pause this video and work at your own pace. Okay? Now I've got one more question from the revision from higher that we're going to work through right now. So this is part E. So it's the integral between the limits of 1 and 3, r squared plus 1 over r squared dr. Okay, so that's your question. What we're going to do is integrate them individually. So the r squared, that's good to go. However, the 1 over r squared, at the minute we cannot integrate that. We need to bring the r squared up to the top and make that a negative power. So everything else can stay the same. We're bringing this up to top. So that's going to be r to the negative 2 dr. Now we're ready for integration. So it's just straightforward integration, increased power, divide by the new power. Like this. This one here, increased power, so that goes to negative 1. Divided by negative 1, square brackets, between the limits of 3 and 1. Now before you go ahead and sub in the limits, I would always simplify this. You could actually skip this step and just go straight to the simplifying part. That's just going to be r cubed over 3 take away 1 over r. So obviously it turns a negative sign. And all I've done is I've brought the r to the negative 1 down to the bottom. That's just in case this comes up in a paper 1 question and you're expected to do this without a calculator. So if we sub in limits, we're going to sub in 3 first of all. So it's going to be 3 cubed over 3, take away 1 over 3, take away, and then sub in 1. So it's 1 cubed over 3, take 1 over 1, which is just 1. Okay, so feel free to pause this, type this all in your calculator. Your final answer that you're going to get is 28 over 3. Okay, so you can double check it on your own by typing it into the calculator. So that's us finished the revision from higher. What we're going to go into right now is the new integrals for advanced higher. So new integrals. Okay, so the first one that I'm going to go through is what is the integral of the exponential, right? Now what I'm going to do is I've got the formula sheet up here. I'll show you this. So this is just a standard formula sheet. The right hand side you've got your standard integrals. Now your exponential is just given to you down at the bottom. Now I would recommend not relying on this formula sheet and just knowing the formula by yourself, because you should know this. So the integral of the exponential, basically your exponential always stays the same, right? And then what you do is you divide by the derivative of the power, which the derivative of the power is just 1 in this case, isn't it? Divide by 1, that's it. Obviously, just do that. So I'll write we know it in here. So exponential stays the same. Comma, divide by the derivative of the power. Okay, so that's the rule for integrating an exponential. Okay, so the one that's given to you in the formula sheet is e to the power of ax plus b dx. So obviously if you integrate this, your exponential stays the same, ax plus b, and you divide by the derivative of the power, which if you pretend that's numbers, your derivative would just be a in this case, and don't forget about your plus c. Okay, so pause this, make sure you've got this into your notes, so you can highlight the sentence we've got here, just to keep yourself right. Now the next new function is the natural log. Now you cannot actually integrate ln, well you can, but that's maybe in unit 2 and further integration, and we're not going to do it yet, that part yet. So I'm just going to write in here, you cannot integrate ln x, just going to put that in modular signs here, in brackets, at the minute. So we'll learn that in further integration, which is unit 2. Oops, went down too far there. But one thing that you can do is, if you've got the integral of 1 over x dx, now this is actually in your formula sheet. So what we do is go back to the formula sheet. If you look here, if you've got 1 over x, the integral of that gives you ln x, which makes sense because if you were to differentiate ln x, you put 1 over the bracket and multiply by the derivative of that, which gives you 1 over x. Okay, so this is going to be ln x plus c. Okay, so that's a straightforward one. What we've also got is something that I like to call the special integral. So if you've got 1 over ax plus b, for example. Okay, so this one's in your formula sheet 2, I think. No, it's not. We'll go through more about this in detail for a later time. Basically, see when you've got something, well, if you look at the bottom of the fraction, if you've got the derivative of that on top, then that's what's called the special integral. So the derivative of the bottom part is a in this case. So what you would need on top is a, then that would become the special integral. We don't have an a on top there, so what I need to do is to counteract that and put a 1 over a just at the front there, and then it's just going to be ln of the bottom. And I've just put modulus signs in here, just so it's a positive. That's an a down there, by the way. Quite messy. So I'll go into this one in more detail later on. Okay. What I'm going to do is just go through, how many have I got? 1, 2, 3, 4, 5, 6, 7 examples of this, and then you can practice these by yourself. So if you write in examples, one A, I want you to work out the integral of e to the power of 2x dx. Okay, so we've got an exponential here. So when we integrate this, the exponential stays the same. And we're going to divide by the derivative of the power. So if you differentiate 2x, you just get 2. And don't forget about your plus c. And that's that finished. That's as easy as that. There's nothing else we can do to this. So part B, you're going to have 1 over 2x dx. So this looks very similar to the one that's in the formula sheet. This is going to be the special case that I was on about. Okay, so see if you've ever got a fraction, right? And see if you look at this, the derivative of the bottom is 2. Have we got a 2 on top? No, we don't. So what I'm going to actually do, you can only do this with numbers, you can't introduce letters, but I can with a number. I'm going to make that into a 2, okay, because I want the derivative of the bottom, I want that on top. I can't just introduce a 2 there. I need to multiply it by something to cancel that out. So if I multiply that by a half, if you were just to cancel off the pink parts, you'll be left with what is in the blue part behind that. Right, and because I've now made this into a special integral, which is what I want, I've got the constant at the front, so it's going to be a half, and it's just going to be ln of the bottom. And always put modular signs when you've got your ln of something. So ln of the bottom. So you can only do this when you've got the derivative of the bottom part on the top. And you can like sort of manipulate it, so you do have that case in some examples. Part C is going to be integral of 3 over 3x plus 2 dx. So whenever you've got a fraction, I would just do a wee check here. Do we have the special integral? Okay, so what is the derivative of the bottom? Right, it's 3. Do you have a 3 on top? Yes, you do. Happy days, we're good to go. This is straight into the special case. So it's just going to be ln of the bottom. And that's it. We don't need to do any manipulation because I've already got the derivative of the bottom on the top. So therefore that's us finished. Okay, right, on to part D. It's going to be the integral of 3 sec squared 3x dx. You might be looking at this thinking, oh my god, how on earth do I do that? This is really straightforward, okay, and we're just going to use the formula sheet. So if I bring this back up, we are given the integral of sec squared ax, where a is 3 in this case, and we're told that it's just this. So it's 1 over a, which is 3, tan of 3x plus c. So it's reading the formula sheet exactly how I've got it. Okay. What I've got here is also a 3 at the front. Okay, so keep the 3 there, right? And then all I'm going to do is use this formula sheet. So what I might do actually is snip this out just so we can look at this. Okay, so that's what's taken from the formula sheet. So if you look back at this, sec squared 3x, so a is going to be 3 in this case. So if we go back to the integral, we've got 1 over a, so it's going to be 1 over 3. Just get my red pen. It's 1 over 3 tan ax, which is 3x in this case, plus c. Okay, it's just reasoning off that formula sheet. And then just simplify the 3 times a third, that just cancels off. The final answer is just going to be tan 3x plus c. Okay, 3 more examples, then you can try some yourself. So the integral of 6e 3x plus 2 dx. Okay, so we've got an exponential here, so everything stays the same. It's the easiest part. I love exponentials for this. Everything stays the same. Then divide by the derivative of that power. So we differentiate the power, you get 3. And don't forget about your plus c. Okay, and then just do your simplifying. 6 over 3 can just be simplified to 2. And then your exponential can just stay as is. And there you go. That's straightforward. Okay, and final, in fact I've got 2 more examples, sorry. I'm going to go through with you, F and G. So F is going to be the integral between the limits of 0 and pi over 8. It's going to be sec squared 2x dx. Okay, so this is where we look at our formula sheet. I've still got it copied, so I'll paste it in here. So this is taken directly from the formula sheet, where a in this case is 2. Okay, so it's as simple as reading off that formula sheet. That's what we're doing. So 1 over a is 2, so it's 1 over 2 tan 2x between the limits of pi over 8 and 0. Now this could be in paper 1 or it could be in paper 2, I don't know. So you need to be prepared and you need to know your exact valued triangles. What I'm going to do first of all is sub in my limits. So if you sub in pi over 8, so tan over 2 times pi over 8, which if you think of this, 2 pi over 8 simplifies just to pi over 4. Take away a half tan of 2 times 0 is just 0. Okay. So this could come up in the non-calculator paper. Okay, so in order to do that, you need to know your exact valued triangles. So if you don't know these, dig out your higher notes, get them written down. So it's 1, 1, root 2, pi over 4, pi over 4. So I've got tan of pi over 4. Okay, so let's look at this one. Soka toa. So opposite over adjacent. 1 over 1, which is just 1. So that part of there is just 1. Take away. Then I've got half times tan of 0. Tan of 0 is just 0. So all this just gives you is a half. And that's it. Now if this was in paper 2, please make sure your calculator is set in radians. Okay, you should not change your calculator into degrees unless the question is in degrees, which we won't see until further on down the line. Okay, now one more example and then I'll stop talking then. So part G. Oops. So it's the integral between the limits of 0 and 1. This one's written slightly different because the dx is on top. And then you've got 3x plus 5. Right, now I'm not a fan of the way this is written. I prefer the dx just at the side. So what I'm going to do is I'm going to rewrite this just so it's in math format. So 3x plus 5 dx. That's the exact same thing. Okay. Now, we've got a fraction. So what I'm thinking in my case is this the special case. So what's the derivative of the bottom? Is a 3. Have you got a 3 on top? No. What I'm going to actually do is I'm going to manipulate it so I do have a 3 on top. Because that's what I want in order to do a special case. But I can't just put a random 3 in there. I need to cancel that off by writing a third. Because a third times 3 just cancels off. Then you're left with what's in the red. So for me doing that, I'm now able to use a special case to integrate this. But you've still got your third at the front. The integral of that part is just ln of the bottom. 3x plus 5. And got limits of 1 and 0. So again, this could be a paper 1 question. Okay, so I'm going to show you how to do this without a calculator. Let's sub in 1 first of all. So we've got a third ln of, so 3 times 1 is 3, add 5, 8. Take away, oh what we've done. So take away a third ln So a third ln, so 0, 3 times 0 is 0, add 5, it's just 5. Okay, now, yeah, if this paper 2, go ahead, type this into your calculator and leave it to at least 3 significant figures. If it's not paper 2, we need to simplify this. So you've actually got a highest common factor here of a third. So what we'll do is take a third out, and what you're left with is just ln 8, take away ln 5. Now, remember from the rules of logs from higher, if you're subtracting two natural logs, what you can actually do is you can divide like the brackets, like the bit, like the 8 and 5. That's only working if you subtract them. This is the exact same as the third ln 8 over 5, like this. You might notice that I've got rid of the modular signs. So the modular signs just make it into a positive, where 8 is a positive anyway, so we don't need those modular signs anymore. And that's you finished. Okay. Now feel free to go back, rewind, have a look at questions if you need some more clarification. I'm going to upload questions and it's going to be questions 12 through to 25. Okay, so please ask if you're stuck at anything. There is one question that I don't like how it's written. Which one is it again? Hold on. There's one that's like find the integral of exp like 6x, something like that. I'm not a fan of writing exp. This is the exact same as saying e to the power of 6x dx, something like that. So this is so much easier. So say if you see exp, just change that to the exponential, and that's that. Okay, so work through these questions and ask if you're stuck at anything.